Hey everybody, in this video we're going to be looking at writing and graphing transformations of a quadratic function. And you can see written right here is vertex form of a quadratic equation, and we are going to be using this extensively. Particularly in this video we're going to be looking at A, H, and K and analyzing, that is breaking down into smaller pieces and looking at what each of those does to the graph of a quadratic function. So before we do that, let's talk a little bit about this parent function y equals x squared. So this is the most generic quadratic that we could possibly have. We've not done anything to it. It is the stock standard quadratic, and it has its vertex, that is highest or lowest point, at 0, 0. This is going to become important because part of what this equation is going to do, specifically h and k, move that vertex around. We also need to know how we find the other points on this quadratic, which hopefully you remember from previous instruction. But from the vertex, for every unit that we go over, left or right, doesn't matter, we go up by 1 unit squared. Or if I go over 2 units, then I would go up by 2 squared, which is 4. So over 1, up 1. Over 2, up 4. If I go over 3 units from the vertex, then I would go up by 3 squared, which of course is 9. And so I can do that in either direction. So over here I can go over 1, up 1, over 2, up 4, and over 3, up 9 to get all the points for my quadratic. So now what I'm going to look at is what happens when I add h and k into this equation. And here's what I mean by h and k. You can see I have 2 quadratics here. Y equals x squared in red, and y equals x minus 2 squared plus 3 in blue. So my h value is this minus 2, and my k value is this plus 3. And what we're interested in is how those two values affected this red graph. Imagine I took this minus 2 and put it inside here with the x, and this plus 3 and put it on the outside. The question is, what did that do to the graph? And we can see that it's the vertex that has changed. The vertex went from 0, 0 to 2, 3. We can see it had the effect of shifting the vertex to the right 2 places and up 3 places. And in fact, if we are to look at that coordinate itself, if we look, the 2 is the opposite of that number that was in the parentheses, and the 3 is that number that was outside the parentheses all by itself. This is the effect of h and k. The value of h shifts the graph either to the left or to the right. In this case, we can see I have a minus 2, and when I look at what I've written here for this example, when I have minus some h value written inside the parentheses, that minus sign tells us that it's a shift of the vertex to the right that many places. Had this been a plus 2, it would have shifted to the left 2 places. The value of k controls the movement of the vertex up or down. Up if you have plus k, down if you have minus k, and we can see that in this case we have a plus 3, so it moved the vertex up 3 places. Now I dearly hope that this seems very familiar from when we did the exact same thing with exponentials, where we had these 2 values, one that was added inside the set of parentheses with the x value, which was an exponent in the exponential equations, and then a k added to the end, and it had the exact same effect in the exact same way. That's because there is no difference in this idea. They both transform those functions in the exact same way. Now that we know that h and k shift the location of the vertex, we can talk about what a does, this value, this coefficient that is outside of the parentheses. Now recall that when I had something like y equals x squared, that I could find points from the vertex by starting at the vertex, 0, 0, and I would go over 1, up 1. Doesn't matter if I go left or right, it's going to be the same on both sides. Over 2, up 4, over 9, up 9, so on and so forth. When I add some value of a as a coefficient of the x squared term, so in this case a 2, the net result is that whatever I was supposed to go up by, I have to multiply by that value of a. So instead of going over 1 and up 1, I have to go over 1, up 2. That 2 coming from the 1 that's right there times the 2 from right there, the value of a. And then I can look at the same thing to find another point from the parent function y equals x squared. I would go over 2 and up 4, but when I have an a value of 2, I instead have to go up by 8, which is that 4 times 2, which again, that 2 is coming from the a. And so we can see that pattern over and over again. And so what essentially happens is that as a gets bigger, so the larger a is, the faster my function gets bigger, and thus the skinnier it gets. So a large a value will make the function very, very skinny, whereas if I have an a value between 0 and 1, that is an a value that is a fraction less than 1, that is going to make my quadratic not increase as fast, and thus makes it wider. Now an interesting thing happens if the value of a is negative. If this happens, it actually changes the concavity of the function, that is, the direction in which the function opens. So our parent function here in red, y equals x squared, opens upward and has a minimum for a vertex. However, if I change this function by adding a, h, and k, I can see the h has shifted my vertex to the left 1 space, and the y has, or the x value, the k value, has shifted the vertex up 5 spaces, so that it is now here. But this -2 as an a value has changed it so that normally where I would go from the vertex over 1 and up 1, that value I increase by, that 1 times -2, then becomes a -2, so I would go over 1 and down 2. If I go over 2 spaces from the vertex, I'm going to change by, normally my amount would be 4, but I have to multiply that now by -2, so I would go over 2 and down 8 to find my new place. So that 2, because it's bigger than 1, has made the graph more narrow, but the negative aspect of it has actually flipped the graph upside down. So now I can take all of this and put it together. I have here an equation with a, h, and k, and I'm asked to graph it as a transformation of the parent function. So the thing I have to know is that for the parent function, my vertex would normally be at 0, 0, but I'm shifting that vertex around a little bit. I have a value right here of -1. So this we represented with the letter h, and this is going to have the effect of shifting the vertex to the right, because it's negative, by 1 space. And then I have this value, the +2, which is going to have the effect of shifting the vertex up by 2 places. And so when I go to graph this, and let's graph this in a nice purple color, I start at 0, 0, and then that vertex gets shifted to the right 1 space and up 2 spaces. So now I have my vertex. When I go to graph the next points, normally I would move over 1 and up 1 and put a point there, and over 2 and up 4 and put a point there, which would be just slightly off the graph at 6. However, I have an A value right over here. And that A value changes the concavity. This A value is negative, so instead of having an upward shaped U, I'm going to have a downward shaped U. And it also impacts the width of this. That 1/2 is going to make it wider, and here's why. I have to go over 1 and then up by 1 times negative 1/2. So 1 times negative 1/2 is negative 1/2. So I would go over 1 and down by 1/2. And normally I would go over 2 and up 4, but now I have to do 4 times negative 1/2. Well, 4 times negative 1/2 is negative 2. So I would go over 2 spaces, down 2 spaces. Over 2, down 2. And then normally I would go over 3 and up 9, but now I have to do 9 times negative 1/2, which is negative 4.5. So I would go down negative 4.5 spaces. I can go over 3 from the vertex in the other direction, and down negative 4.5 spaces. And we can see very clearly how the axis of symmetry is cutting this in half. And I can go ahead and do the best that I can on a computer. I'm sorry, my drawing skills are quite terrible, to flesh out that quadratic. Finally, if given a graph, I can write the equation of a transformed function. And so in order to do this, I have to remember that my equation is going to look like y equals a times x minus h squared plus k. And so the first thing I need to do is find out how the vertex has been shifted. We know it would normally start at 0, 0, but if I look at where it's at, it has been shifted now to the right 2 places and down 4 spaces. So let me emphasize here that that is down to the 4, or down 4, and right 2. So when we go to write this, we know that if I am moving to the right, I'm going to have x minus that many spaces, so x minus 2 squared. And if I'm moving down, my k value has to be subtracted away from things. And so it's going to look like this. Y equals a times x minus 2 squared minus 4. So now I have adjusted how the vertex is shifted. Next I have to look at the rate of change. So let's get rid of this right here so that we can focus on that. Now normally we would expect from our vertex to move over 1 and up 1. But instead of going up by 1, we can see that we instead went up by 1, 2, 3. So our expected increase was 1, and then we instead went up by 3. So in order to figure out what it is, I have to know what number I multiplied times 1 to give 3. Well, that's easy. If I do 3 divided by 1, it's going to be 3. So I know that y equals 3 times x minus 2 squared minus 4. So again, I've shifted to the right 2 units, I've shifted down 4 units for my vertex, and then where I would expect to go over 1 and up 1, instead I do 1 times 3, and so it goes up 3 spaces. Now I can check using my second point to see if this is correct. We would expect to go over 2 and up by 4 times 3, which is 12. And here we can see on the graph we've gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So our equation is correct. So to recap, A changes the rate of change of the quadratic. If it's negative, that flips the concavity so that it is upside down from how we usually see it, concave down rather. H shifts to the left or to the right. Minus H is to the left, plus H is to the right. Excuse me, have that backwards. Plus H, if this is a plus value here, that will move it to the left, and a minus to the right, excuse me. And we have our K value, which shifts it up or down, positive up, negative down.